students learn best when they can see connections between their personal experience and the material that they're trying to learn. This is what educators refer to as an authentic classroom or authentic assessment. And the way that textbook authors often do this is by including pages of word problems, problems that talk about real-world situations and events. Now, the problem with this is that these problems often don't describe situations that would actually happen in a real-world setting. For example, I read a question once in an algebra textbook where the author gave an example of a quadratic equation, something like s equals 0.1x minus x squared, that he claimed described the number of tickets sold by an opera company for a given price. Now, when I was younger, I spent several years doing report development for a large computer sales organization, and if I had presented that kind of equation, no one would have been interested in it. I would have been quizzed on whether it worked for every region, whether it worked for all types and sizes of accounts, whether it worked for all kinds of products. You know, ultimately, with this question, I felt that the author had taken a reasonable business question about finding the best price for a product and just kind of grafted a quadratic equation onto it. Now, with that said, I do think that application problems have an important place in math education. I just think they need to be done a lot better than what we're currently seeing in textbooks. Now, one solution that I like to use in the classes that I teach and that I design is called project-based learning. In this kind of a classroom, lessons are built around projects that demonstrate how the material is used in real-world situations. Now, these projects are generally a lot larger than a single word problem. They're more open-ended, and they should have a strong connection to a practical application. This kind of project or this kind of classroom is a great approach to teaching math because it encourages students to go beyond just coming up with an equation, doing a calculation, and there's the final answer. It gives students time to really think through more complex problems, often working in groups, and lets them develop solutions rather than just coming up with the single correct equation, then finding its solution and presenting the result. Now, when I'm designing this kind of project, there are two broad categories that I try to develop. The first is the classic practical problem situation. And these projects involve using math to solve some kind of open-ended real-world problem. For example, when I teach statistics, I have a project where students analyze data for a real baseball team. Real, actual data collected for a major league team. And they're given the data, but they get to choose which statistical tools that they use to evaluate the team's performance. And not only do they have to do the analysis, the calculations, but they also have to explain the reasoning behind the tools they chose to use in doing that. Projects like this are a great opportunity for us to customize our classrooms to meet, not just the learning outcomes, but also the personal interests of the students. Now, the second type of project is what I call an investigational project. If you've seen our video on What is Math, where I talk about the two approaches to mathematics, this kind of project falls on the theoretical side. They're designed to give students an opportunity to investigate a mathematical concept in detail. For example, when I teach absolute value in algebra classes, I have a project where students graph different absolute value functions to get a visual idea of what they do. For example, I'll have them graph y equals the absolute value of x and y equals x. Now, if visually, just looking at the formulas here, they seem very similar. And when students graph them and really can kind of see side by side what the effect of adding that absolute value to the function has. Now, so what does this mean for students? Well, that's a tough question. The reality is that math teachers, math professors, are highly trained in math, the theoretical subject, and not so much in math, the applied subject. Applications in subjects like physics, business, nursing, they just aren't a part of their training. Now, I'm sure that many teachers are researching and learning about these things to bring them into their classrooms, and that's great. But don't be surprised if your teachers maybe don't have much to offer in this area. Now, that doesn't mean that you can't find these approaches. You're just going to have to invest the time in going out and finding them for yourself. From a teacher's perspective, this approach often means more work in terms of expanding your knowledge and seeking out new applications, but my personal opinion and my personal experience is that it's going to be worth the effort. At White Crane Education, we're building a collection of case studies that you can find at the address on the screen. Now, these aren't strictly speaking projects in the sense that I was talking about them on the previous slide, but the material in them can help you to get thinking about new content and thinking about ways that you can bring these ideas into your classroom.